Software's eating the world, but AI's eating that too. Ship, learn, fix, that's how we get AI right. Look at your fucking data, keep that quality tight. Out of the lab, into the field, time to deploy. Real world problems, real solutions, that's what we employ.
Welcome back to How AI is Built. This is Nicolay, and today I'm talking to Charles from Modal, who went from doing a PhD on neural network optimization in the 2010s, when ML engineers could build models with soldering iron and some sticks, to architecting serverless infrastructure for AI. Modal is about removing barriers so anyone can spin up 100 GPUs in seconds. And the critical insight is, don't build models, but build systems that build models. Organizations often make the mistake of celebrating a one-time fine-tuned models that matches GPT-4's performance, only to watch it become obsolete when the next new foundation models arrives, which is typically 3 to 6 months down the road. And the winning approach usually is you have automated data pipelines with feedback collection. You have a continuous evaluation against new foundation models. You have A/B testing and canary deployments, and you have a systematic error analysis and retraining. And in this episode, we will go into each of those. Let's do it. How do you actually think about when a developer comes new to Modal and he's mostly used to corporate environments, so he's using EC2, Kubernetes. How should he rethink compute when he comes to Modal?
I think the biggest one is your ability to sort of be ambitious with scale. It's there's just so much that gets in the way of trying to spin up 100 GPUs or 1,000 CPU containers, even if you are using a hosted Kubernetes service, that a lot of people just don't think to do something big, scrape all of Wikipedia or follow every link on Reddit or whatever. Or people are would be really hard to run my own language models, so I'll just use a hosted service instead. So part of it is that ambition. And then the other part of it is sort of the economics of automated resource management, this serverless approach. It means that you can get a hold of a ton of resources for some small task and then just let them go. And because the cleanup is handled automatically for you, you don't have to worry about how do I make sure that I've maximally used these resources. It's an even more extreme version of the cattle versus pets thing that's generally the case in the cloud, where it's previously when it was on-prem, you'd have a small number of machines that you carefully managed, and then you tried to pack as much work into them. And then when you move to the cloud in the 2010s, it was it's a bunch of cheap machines, they fail more readily, but we have a bunch of them and we have automatic failover. But then you would still you would get a machine and you would hope to run on it for days, weeks, months. And with Modal and with the serverless approach, it's let's just run on this. The individual machine doesn't matter anymore. It's maybe we allocate this resource to ourselves for 5 minutes to use it and then let it go. So it's just sort of realizing where your persisting state where you don't need to, where you're where you're limiting your reach or limiting your compute power just because of availability, not because of the inherent structure of the problem you're trying to solve.
Is there a similar misconception when people come from the serverless side of lambdas? Is there something they think wrongly about when it comes to Modal?
Yeah, I think people who have more experience with serverless platforms in general, get the value proposition and get the way to use it more quickly. I think they're surprised at how easy it is to use. I did a bunch of I taught full stack deep learning in 2022, how to deploy neural networks. And we told people, deploy on AWS, make your model small enough that you can deploy it on AWS Lambda. These are computer vision models. They're 1 to 2 orders of magnitude smaller than the models that we're using today. Maybe actually 2 to 4, maybe actually it's smaller, orders of magnitude smaller. And you could fit them on on inside an AWS Lambda. But I think especially with Lambda, because they were like, to give them credit, like they were first. They figured this out when it was like zip files and not containers. Like if you complain about the Docker file format all you want, but like when AWS Lambda on launch was like, give us a zip file with all of your requirements and stuff in it, and we'll serve it. Right? They figured it out at that point. And then, so like, there's some limitations there on sort of like size, scale, etc. But it was designed for like almost like middleware or stuff that's like kind of like while you're running a website where the two most important pieces are the database and like the like, web server to the client. There's like other stuff you might want to do. And it's like also probably going to like either talk to the client or more likely like talk back to the database or talk to other services, produce logging. It was sort of this like back of house, middle of the stack stuff. And so these things needed to be super small. They're like taking in a few bytes or kilobytes, emitting a few bytes or kilobytes. And so the system was designed around those things. And whereas Modal is designed around something that might take in bytes and emit megabytes, like it takes in a prompt and emits a video, based off of a container image that is many gigabytes of non-shared information, right? Like AWS Lambda, everybody's running like one of 3 or 4 different basic like operating systems. And so their images share like all of these bytes that can be sort of like cached and shared between tenants. But with especially with custom models, everybody's got their own private, like many gigabytes of data that they need, like moved around to each replica. And so a bunch of that fundamental difference means that a bunch of stuff is really hard with AWS Lambda, which is like maintaining like a long running connection between a client like that's requesting a resource that's coming out of a Lambda, or like sending a lot of data in, getting a lot of data out. That is like Modal makes that really easy. So some people come in and they were like, oh yeah, I exactly identified the problem. I was trying to do this with AWS Lambda and Modal's made it easy. And that's kind of how I came in. So lots of those people sort of like, if they come in without recognizing that, they're sort of surprised to discover it. I guess maybe the other side is that Modal's more than just like Lambda with GPUs, which is like the impression I had at the very beginning. Like, I was looking for ways to deploy my neural network models. I needed GPUs. I was tired of AWS Lambdas, like IAM role complexities and like lack of hardware. But then the thing, like, so I came in for that, and then I was like, oh wait, they also have this like queuing system. It's like, write a couple lines of Python, and now I have a queue, and a dictionary for managing job state. Oh wow, it makes it like super easy not just to run this as some like total backend process, but actually to like wrap a Gradio UI that I serve from Python at the same time, so that like when I'm training my models, I can actually just like take those model weights and like just create a web dashboard for them in like, another 5 more lines of code. So it was like actually like the existence of all these other sort of like bones or core components of good infrastructure. That's maybe the sort of like thing that people miss if they just come in with this like, oh yeah, hell yeah, Lambda with GPUs.
The most impressive thing to me is just like rebuilding all of the different components from scratch, like from buckets to queues and different data structures, and making it really seamless and easy to use. Like if just the key value store as if it would be like a Python dictionary, which is just like really nice to have.
Yeah, the founder spent a long time kind of like in the wilderness, just like getting all these pieces together. And then it was like once they attached the GPUs at around the time that like people got excited about diffusion models, and then shortly afterwards about language models, then the product market fit hit, right? It was like, that was the sort of that got people like me to pay attention and then discover all these other features. And there's something kind of similar happening now. Modal recently added these like sandboxing features so that you can sort of like spin up a container in this completely isolated environment, and run code, or like execute tasks. And that like was built, started working on that like probably 2 years ago, even sort of like looking forward at this agent stuff, and it's now turned out to be very valuable for people.
Why do you actually think inference is where the money is?
Yeah, there's a simple answer, which is like almost nobody gets paid to make models. By which, people get paid as engineers to make models, but organizations don't get paid to make models, right? At best, organizations get paid to make predictions, and then having a model that can make those predictions is valuable, right? But then you have to use the model to make the predictions. That in the like classic ML world, maybe you would spend actually quite a bit more flops, quite a bit more compute power on training the model, and then you would make like if you believed in it. And I'm thinking of like econometrics models, right? Like you fit to historical data trading models. You like spend a ton of time fitting them to historical data, back testing, etc., running them in simulation, and then you finally like run them for real. And then like, maybe your trading model like rots within a few days, and then you have to like put out a new one. And then so like the total amount of effort there is like more on the modeling than on the inference. But that's not really the way things are shaking out with this switch over to like foundation models, where like one team or a small set of teams are the only ones who are capable of producing these super large, generally useful models. And then those get used over and over again, all over, by many different people. I think it's also notable that we have ended up with a bunch of open source models, which is to say, like, people are releasing the models for free. What that usually indicates is that there's some sort of non-differentiating capability, right? Like running a database is critical. Like almost every business in the at least like the rich world like runs off of databases, right? I've run like parties at my house that have a database, right? It's like so critical, but it's also undifferentiated, right? Like everybody needs it, and they all need like the same basic set of things, especially because people have come up with these really elegant interfaces like SQL that like abstract away a lot of the storage, like the details of storage, and it's like, yeah, it's actual execution. So it's just like it's not that like combination of like everybody needs it, but nobody like needs to do a super good job at it to win, is when you end up with this like these like an open solution, like people collaborating, working together to produce a solution. And that seems like it's where we're going with model production. So, it's a long-winded way to just get to the point that the like model itself is turning out not to be something you could like charge people for. So like the training process is not something you can be like directly monetized in any way, in much the same way that you can't like, in many cases, you can't really directly monetize like writing the database software. But you can monetize the outputs of models, or you can monetize the like integration of the model's outputs with the rest of a software system, which is like maybe several models working in concert. It's models working in concert with tools like models writing code that then gets executed, models interacting with APIs under their own control, which is this sort of like agent thing people talk about, or just like the outputs of the model being like parsed and turned into something that can be used like in the rest of the software system. And so that's the thing that people will actually like. People will pay you money for the value that is delivered there. And so inference ends up being the place where money gets made. There's maybe like one little step from like literal raw, like maybe people originally thought like, oh, I'll stand up a model API and people will like, I'll be able to charge people for the model outputs. And that has become this like pretty aggressive race to the bottom on price. So it's sort of like inference integrated with software systems into like an application of a model is where like you really start to see like value delivery and value capture in the form of revenue.
How do you think people will differentiate? Is it data? Is it better distribution, better UI and UX?
Yeah, I think we'll see all of those things. I think this is like a big enough, this is a big enough idea. It's a big enough software change that all of those are going to be important. I think distribution is very important. So being able to, in part because distribution's usually paired with sort of bundling, I think, and that bundling usually gets you access to better data. So if you're Apple, Apple already has this tightly integrated stack all the way from the hardware up to the highest levels of the software. And so they could perhaps do things that would be extremely difficult for somebody just coming in and building on top of that stack to do on their own. They can they have, sort of privileged, they know about all of your time machine backups, they can see the evolution of your computer system over time. I think the challenge and the reason why we aren't seeing an immediate, total victory for Google, Microsoft, Apple, a couple of, organizations that have this incredible distribution, existing tech stack, installed base, is that there's a trust component, and it's there is these models erode security boundaries. They can't be prevented from shedding information, and there's a general, we've had over the last decade and a half, there's been a massive decrease in trust of technology companies, and so people are, there's not a good reason to sort of trust these large organizations, and just on the security merits of the technology, and then people are coming in at a high baseline level of distrust. So that makes it hard for them to truly make use of that distribution and that integration. I think that I'm in talking about those things, I'm kind of thinking on the 3 to 5 year timeline, where it's oh yeah, somebody's gonna wrap your operating system. They're gonna ship a version of Finder that has AI features, or the AI conversation summaries that Apple does. The thinking longer term, I think it is the real wins are to really rethink the entire system and what its interface and experience are from the ground up, assuming that we have semantic understanding of bytes that we didn't have before. Previously we had purely syntactic understanding of bytes, and we built a whole computing edifice on it. But now we have reasonable semantic understanding of all the images, all the text, all the audio. What does a computer system look like with that assumption built in from the beginning? And that both because that's a bigger, harder problem, it's extremely difficult for the existing organizations to tackle that. And because the models probably aren't quite good enough yet to really deliver on that vision. For all those reasons, that's the sort of thing where I think that's going to take 7-10 years to truly deliver on that. And is where I think an ambitious startup or a venture capitalist searching for ambitious startups should be looking.
Yeah. Do you think we will move into a direction where it becomes more about task decomposition into multiple micro models, microservices, each of which specializes into a subtask?
Yeah, I think one of the blockers on that right now, there's a lot of salty people in the world of ML. I did a PhD on neural network optimization in the 2010s. It's a much smaller community. People were focused on relatively narrow tasks, a lot of academics. And they look at what people are currently doing with prompting foundation models, and they're I could do that with a model 1,000th the size, in a garage with a soldering iron and some sticks, right? And they're not wrong. It's just that the big unlock recently is that the barrier to entry and the effort required to get 90% of the performance per dollar that you would get 10 years ago, that landscape has shifted, not in terms It's definitely in some places in terms of the absolute capabilities, but in a lot of tasks where people are doing, I don't know, RAG and support chatbots and like, I don't know, even like sentiment classification with large language models on their like customer data. Um, like it's actually about like what can people quickly and easily find value in, what can people prototype effectively. So while it's definitely possible that like everybody learns a bunch more ML and then we all get really good at ML and then the foundation models additionally make it easier to like fine tune. And so then people start creating these like, micro models on their own that are either distillations of the large models like, or somehow derived from them. I think the engineering difficulty there is just so much higher, and it's substantially harder to automate, like to turn it into something where you just have like a high level interface where you like specify a problem and then just walk away. Like ML has always required a lot more like attention to your data, like care and like precision and experimentation. And so it's hard to imagine it becoming like truly, oh yeah, I just like specify my problem declaratively and then like the machine learning system just like, improves itself over time. And so like for both those reasons, like I would love to see that. I think we will see we over the last year we have seen more fine tuning, I think, and more people realizing that they want to customize foundation models. But it I think it has substantial engineering costs that have to be like justified. And so I'm not hopeful that it's going to like consume the entirety of what's being done with foundation models today, for example.
Yeah, I think you have like at the moment, like the easy path is like you start with a big model, you prompt, you collect data, and then at some point you start fine tuning a model or you decompose the task. And I think if you extrapolate like your assumption out, we will have like training can't be monetized, but only the outputs and outcomes. We will move, I think, into a direction where either we have like a few model providers which have massive models which can perform really well at all tasks, or we make it so easy that you actually can decompose into different models that everyone can participate and do it easily. And I think these are like the two extremes. And the second part, I think, is also really challenging because only really advanced engineering organizations are likely able to do it.
Yeah. I would say, the one part of what you said originally and mentioned again in your second question is like task decomposition or like splitting something up into like smaller component parts. I think that skill for ML engineering is like the equivalent of like some of the key skills in software engineering of like recognizing where there should be an API boundary, what's like a single concern versus what's actually multiple concerns. It is critical for being able to do something like fine tuning effectively or to build like an automated improvement system for ML. Like if you get like when you take the like high level problem of like booking a flight is way too big to effectively build like an evaluation or automated improvement system. But if you split it up into smaller steps, maybe you can effectively supervise each of those steps, and then the effort required to supervise the composition of those steps is way smaller. So I think that's partly like an engineering skill that people have to learn. Like ML engineers kind of went the other direction, which is like ML engineers were learning like what is like a tiny task that I can frame, and then oh by the way, it happens to be useful once you compose it with other things. And switching that around and being like, okay, I start with a system that works okay, it works 90% of the time or whatever at booking flights. How do I get it up to 99% by breaking that down into pieces, each of which is this like, actually testable or verifiable sub piece.
Yeah, I think like I love this this because it's like a system perspective. Like you start with a simple solution to a problem and then you move into something more complex where the sum is like greater than each part. what I'm really curious about is like how many people actually deploy like these really large models, like the Llama 350 billion and the DeepSeek V3 or R1 on Modal.
Yeah, I think our platform isn't yet great for deploying these like the largest language models. The like fundamental problem is that we're like distributing work out to a bunch of workers. Those workers are going to need access to these like hundreds of gigabytes worth of data that like make up the weights of the models. And, there's limits to how quickly you can move that around. And it's like, couple, like right now in our system, it's like a couple gigabytes a second, which is pretty fast, but it like, objectively, it's like incredibly fast when you think about it. Like, yeah, billions of bytes moving in a second. But subjectively, as a person like waiting for a language model to respond in a chat situation, like waiting 90 seconds for the thing to start responding is like untenable. I'll say like the thing that does work well with the large models on the Modal platform is like batch inference. You like you spin the thing up, send a bunch of prompts at once, get a bunch of responses back. And that's sort of like, data annotation or processing, like summarization, annotation. Those things actually work reasonably well. I would say like the primary interest in using these models is, I think it's twofold. One that's like one is like looking now, and one is looking a little bit to the future. Looking now, people are like, oh, you know what? I actually, I have data governance requirements that mean I have to run this like myself. Like I can't send data to, an untrustworthy political entity like China or the United States. And so I have to run this myself. So that's one good reason people want to do it. I think the other good reason people bring up that's like looking a little bit further forward is, oh yeah, sure, like maybe running this model via an API would be cheaper right now, or maybe OpenAI would offer like a better dollar to performance trade-off today. But um the the long-term trajectory right now is that the open source models like keep getting better, and that any fixed sort of like level of capabilities gets like commoditized very rapidly, and the price drops very rapidly. And so while there might not be a great like, economic argument, for example, to run DeepSeek in AWS Bedrock as a managed service is like $6 per megatoken. Whereas DeepSeek is, I want to say $2 a megatoken, maybe less, and they claim to be able to serve it at like 20% of that price or 10% of that price. Like it's extremely challenging to serve this inference economically right now, but it's likely to become like more economical in the near future. And so it's like, as an organization, how do I prepare my teams? How do I see this interest from, in particular, like larger organizations, longer lived organizations in, healthcare, finance, insurance. They're thinking like, okay, in 5 years, when this is like way easier to run ourselves and where many more factors will tilt in the favor of running on inference, let's get ready for that now by upskilling our teams on what it takes to run an inference service, even if it's like not economical, so that we're prepared for that future.
I'm still really torn whether companies should host the inference of general models rather than task-specific models, because I think like you can get like so much done with more task-specific models where you distill down from like more general models and just host them, which is like the trend we are seeing with all the like R1 clones as well, that you can get like the capabilities into a 70 billion parameter model, which you can host on like a smaller cluster or like a pretty small one.
Yeah, definitely. We do see people coming with their like, I spent a while talking about something that, doesn't work well on Modal yet. Not until we get some features with GPU memory snapshotting and similar things working better. But the thing that does work well right now is people come with their like 7 billion parameter, 14 billion parameter, whatever language model, like fine-tune or distill, and then they want to run it, and that can fit on a single GPU, and like a single GPU can handle a non-trivial amount of traffic, and then like the time to scale up a new replica is on the order of seconds instead of like a minute or more for these large models. And then a lot of these people are finding, oh yeah, I got this great, out of the box 9 months ago, I got great performance with GPT-4o. But we quickly figured out that we could fine tune our own model. We could take, a Qwen coder. We could take a Llama 8B, and we could just, fine tune it and get the same performance on all of our benchmarks and vibe checks. And yeah, so I definitely see that as like a trend as things mature. I guess the thing to watch out for, and I think that, the mistake people make is they over index on the actual like model weights and the actual like model that they have produced, which is to say like they like sprint, or they like build this like pipeline that delivers the model one time, and then they build something to evaluate it against like GPT-4o or whatever their existing solution is, but they don't build that in a way that it's repeatable, and they can like build a new model a while later out of distilling out of some like alternative, like new better model that gets released by one of the proprietary model providers. They don't build this repeatable system for producing models that then like can actually sort of, accumulate value over time and drive like multiple rounds of iteration and improvement on the core model. So it's like, you want to make sure that you don't just like output a better financial prediction model or whatever at the end. So yeah, in the end, like this is basically what an ML engineering team exists to do. It exists to build this like system that builds models at, whatever degree of automation is possible. But even just like framing the problem that way helps you ensure that you aren't just like, you work really hard, you deliver this like 8 billion parameter fine tune. Now it like is cheaper and matches the performance of this foundation model you were using. But Anthropic just released a new model and it's like 100 times cheaper in tokens per second. Oh, and it actually like seems pretty good. Maybe it actually beats your model on benchmarks. How do you even know that it like beats the previous system you were comparing against or your new system? And then how do you make use of this new superior system to like improve and like build a new fine-tuned model? Or when a new base model is released by one of the open model providers, how do you like, quickly take advantage of that to improve your capabilities? I think because we exist in a place where people are like competing on the quality of these capabilities, you do need to like repeatedly iterate on this and not just deliver static weights.
Yeah, I think like when we talk to clients, like what we talk about is like you have to earn the right to fine tune. Like there has to be so much stuff in place, like data automation. You have actually like feedback collection in place. Everything is logged, inputs and outputs. You have systems in place to get your people to label the data and correct it, to find mistakes, to do error analysis, and an automatic fine-tuning, and an automated way to actually know whether the model is better, and even like automated rollbacks, and also like testing like A/B or canary in production.
Yeah, absolutely.
I'm really curious about like with the sizes of models, like where model breaks. Is it like at the point where you have to span GPUs, so model is really great at single GPU inference? Or is it like single cluster, single node?
So I guess in terms of like what can literally be run on the platform, if you don't have a like any particular like latency or throughput targets, you can run across, I think, in our alpha multi-node deployment setups, I think you can do either 32 or 64 H100s. And so that's like, you can fit a trillion parameter model onto that. So I don't think that there exists a model so big, publicly known, that you can't run inference on Modal. So like the cut points, yeah, as you said, are like the cut points for where your like performance will change, your engineering complexity will go way up. Are like, are you distributing inference across multiple nodes? Okay, great. Now during inference, maybe you have to like pass, you're going to be like passing a reasonable number of bytes over an IP connection, and that's going to limit your throughput. That's going to be your bottleneck. I think, that's going to bottleneck your latency in many cases. Is actually not so bad for throughput. So if you have a very you want to run a large model on a lot of data, but you don't have like a tight latency requirement because it's like a batch job, nightly batch job, like that actually will work fine. If you want to avoid that extra latency, getting down onto multiple GPUs on a single node, that cuts that latency, that communication latency down. And Modal, that is a much more mature part of the Modal platform as well. Like we have this multi-node setup, but it's still relatively immature. If you're listening to this and you're interested in multi-node training or very large model batch inference, let us know, because we're still working with design partners and could use a few more. But yeah, multi-GPU, that setup like works like, both Modal as a platform is mature for that, and the like software stack around it is very mature. There's like a bunch of torch distributed libraries, like also just like general distributed communication libraries. But even at that, like there, the problem is more that as the model gets bigger, it makes less sense to run things in this like serverless fashion, because scale ups take more time the larger the model is. So like if your model is 4 to 5 billion parameters, each parameter is 2 bytes. So there's like 800 gigabytes that need to move. That's going to take like 5 minutes, 10 minutes maybe for us to those model weights to be like on that server ready to go. So I think there are potential technical solutions, like you could do smarter things, like manage some like caches of these weights in places where there's higher bandwidth, and try and detect when people are loading them and load from that cache instead. So for running like general models, there's also there's also more exotic things, like if we needed to go like an order of magnitude faster or more, then it's like RDMA. Like, so then it's not just like a disk cache somewhere, but we just like directly read into the GPU memory from another GPU's memory, for example. But yeah, so these are like solvable things, and it just depends on like what do people want, what do people need? Is there enough demand to justify that engineering solution? So I think we can if it moves over and turns out everybody just wants to run models that big and only that big, there's like technical solutions to that. But the thing will run. It's just, is this the platform that has the right engineering affordances to like hit your latency targets and your throughput targets at like the lowest cost, or at the right balance of cost and developer experience. And so the sweet spot for that, I think, is models up to, let's call it like 14 billion or 20 billion parameters, which readily fit on a single GPU, load in 10, 20 seconds. Then the like other advantages of the serverless platform like start to make sense over like running more long-lived servers.
Yeah. And also I think like on economies of scale of having a lot of GPUs, it pays to be in like a serverless fashion where like not one massive models takes like a whole chunk of your infrastructure for a long time, because you would have to charge like an exorbitant amount or like a respective amount for that, for it actually to make sense from your perspective.
Yeah, I think interesting thing about GPUs is that you can't really slice them up the way that you slice up CPUs. Like there's two reasons I think for that. The upshot here, by the way, is that like we don't really like pack 3 or 4 users onto one GPU, for example. Like we'll split the 8 GPUs on one node among users, but we won't like, run multiple users' workloads on one GPU. Whereas like a physical CPU is like switching between multiple tenants' workloads all the time. A single like block of RAM has memory allocated from multiple users. And the like one reason for this is just that like GPUs come from this like workstation and personal computing era, right? Like gamers using their GPUs and like graphics rendering from like even going back to like silicon graphics workstations. And those like it's basically a single tenant environment. Like you barely even need the like process level isolation of a CPU because it's like just totally it's like basically trusted. And so whereas like the operating systems people use today for CPUs and and all the CPU hardware people still use to this day was like originally designed for these multi-tenant mainframes with all this like task switching and resource virtualization and sharing. The other reason, and that's kind of like a historical reason. The other reason is a little bit harder, that could be changed, that could be fixed. The other reason is that GPUs are like for high performance computing, and people tend to saturate at least one of the GPU's resources while they're running. And then, so if they share it at all, they will notice that there will be a decrement in performance, which is not really true. Like many people can run a web server off of the same hardware without noticing each other. Right, up to very high performance requirements. You can just like most of the stuff is actually being handled by the hardware, right, and like by drivers like pushing stuff out to network interfaces, and the operating system and your programmer are just there to like when bytes arrive, like do a few quick transformations on them and send them back out. And that is. That's like not really the way and so there's no real part of the system that you're really pushing to its limits on throughput or latency, really. Whereas with GPUs, usually some part of it, whether that's the memory bandwidth, the arithmetic bandwidth, the scheduling onto the cores, something is frequently running like at or close to 100%. And then if you share it if you like attempt to share it with somebody, both of your workloads run slower. And that's like, especially true of these like highly optimized code bases for foundation models that people use. And so that means we don't actually do this that much, bin packing for GPU workloads.
Yeah. What I would love to know is like, what are some of the more advanced patterns that you have seen how Modal is integrated into the MLOps lifecycle? Because you talked before about like you need that like factory-like setup. The models are automatically created and promoted.
Yep. Let's see. There's a couple things like on the inference side. I think we've talked a lot about this, so I won't spend too much time. But definitely, like on the inference side, you can frequently separate out different subcomponents of inference onto different infrastructure. And once you have a certain degree of scale, that's like very much justified. So with language models, that would be like disaggregating prefill and decoding onto different infrastructure, which, the DeepSeek paper, they talk about doing this for their inference. I think it's pretty standard for large scale LLM deployments, but that's something you can do on Modal. Then, and similarly with other things, it's like pre-processing with images and audio, like the non-text inputs frequently require like quite a bit of like munging and management that's actually fairly compute intensive or resource intensive and can be split onto separate hardware. And then Modal gives you like separate auto scaling pools for all of these, which is nice. So that's just on the inference side. More on the ML ops side, I'd say Modal does make it easier to write sort of like a training loop that recovers nicely. So you save to a modal like volume to our like distributed storage, and then like if you just set like a retry flag on your function, and then if your training crashes in the middle, will just like, we will transparently retry your training. And all you need to do is write the logic so that like you check for checkpoints and then continue. And then that way, like you'll find the like last checkpoint saved to distributed volume when you restart training. And we'll just like transparently do that retry for you. Another one, this is one that I'm a huge fan of as like somebody who is at Weights and Biases and worked on, experiment management and evaluation. And then also at Gantry, thinking about continual improvement and model monitoring. While training, you're saving the weights to distributed storage the entire time. That's like as easy in Modal as like saving it locally. You have like you deploy a separate application that checks for new checkpoints and then like runs your evals on them. Or like you deploy another, app, like Modal application that just allows you to like scroll through your available endpoints and like, pull up a Jupyter notebook and play around with a model that's like just finished its epoch like a couple minutes ago. Or turn it into a Gradio UI so that you can like try out some inputs and see whether the model's improving on one of your favorite test cases. In both of those cases, that's like before you even turn it into an eval. So you're able, and the reason why people like frequently don't do that is first, like if you do it during training, you do it like on the same hardware that you're doing the training on, it's going to slow training down, right? And you're adding like, doing autoregressive sampling might take as long as doing a whole nother batch. Right, like one autoregressive sample might take as long as like a whole batch forwards and backwards, and so it's like the payoff isn't really there, and it's like increasing the cost of your training and decreasing and like worsening your latency. So people tend not to do it, and then like people recognize, oh right, I could do this if I just had some extra infrastructure to run my evals on, but if you aren't in this like serverless environment, then it's not as simple to just like, oh yeah, I'll just get another GPU to run stuff on. You either need to like slice off some of your training infrastructure for this. You probably need to set up like some sort of like Slurm or Kubernetes thing for like submitting eval jobs. And now there's like an extra several layers of infrastructure and like bookkeeping and tedium in between like your ML team and actually finding out whether their models are getting better. And so that's something I've seen a couple of people do this with Modal. And it's one of the things I'm like most excited about just like personally, because it's like a cool intersection of a bunch of my interests.
What is orchestrating like the different calls? Because when you have like a processing pipeline, pre-processing pipeline, inference, post-processing, I think you could either like pass between them, have like basically the AWS model where you store to like a bucket and an event triggers like the next inference, or you have like an orchestrator node which handles basically the different calls. What are the like modal native patterns which you have seen work best?
Yeah, so the first modal native pattern, the one that hopefully things work for, is just like, function calling, right? Like, yeah, directly, like you call the pre-processing pipeline, it returns results to the inference function, which returns its results to the post-processing, and just like, things move nice and smoothly. There, like we have things like retries, and like we have increased reliability and robustness there over like just setting that up like raw EC2 instances. So I think it actually does cover more cases than like Modal will take that to like a higher level of robustness and higher performance characteristics than just building that yourself. But if that doesn't work, then the like next layer above that would be to use like modal queues, which are these little, it's just like a, very similar to a Redis queue, but you just like use it from Python. And that allows you to like push work from one place and pull work from one or more other places. And so I think once people get up to
producer consumer.
Yeah. It's very, so you can totally do that sort of thing. And it actually has, I think we have like keyed queues at this point. So it's like not that different from a dictionary. But these like, yeah, so then you have this like this thing that looks, very like, producer consumery. I think I'm not sure if that would automatically apply back pressure or not, which is important for getting that to work super well. I think you would have, you would have to write a little bit of logic to like try and then like back off. But that then extends you over another like, range of engineering complexity or performance requirements or reliability requirements, to like go from just like directly passing stuff to storing things on these queues. And then you can certainly like implement either with modals abstractions over buckets or just directly with buckets, the sort of like write something, notify, consume pattern. Or like, honestly, at that point, I would be tempted to just like put these things in some kind of like, I would reach for a database before reaching for the sort of like SNS notification style stuff. Probably like maybe a managed AWS, like a managed cloud provider system for like pushing stuff and then pulling it out somewhere else. Ideally, modal queues handle that for you. And over time, we intend to build like additional layers on top of these things so that you can use like modals managed like queuing and notification service, built on top of the like other components. But yeah.
I'm still waiting for basically the temporal clone from Modal, making temporal more usable.
Yeah, I mean, they totally use them together. I think Temporal has some stuff in their docs about using modal with Temporal. Definitely have seen some people like build POCs and stuff along with other orchestrators. But yeah, orchestrator would be a great thing for us to build. I think, again, it's sort of like build a bunch of like bones or fundamental components, then start building on top of them, maybe realize you need another bone, go back, and then now I can build this up. So it's a matter both of like, sort of engineering preparation, build the things properly and iteratively, and then also finding the right customer to help us build it robustly and properly.
Yeah. And what's next for you guys? Like, what's on the horizon that you can already teaser?
Yeah, I think the biggest thing is getting multi-node training working and highly performant. Like, it's the sort of thing where, serverless platforms work really nicely because you have this like very peaky demand, right? You want to run a training job, then you don't want to run a training job for a while. Oh, I want to run a hyperparameter sweep, so now I want to run 100 training jobs, then I don't want to run any for a while. And so it has this very spiky demand that is naturally served by a serverless platform. It's a bunch of tricky stuff to get right there. Serverless high performance computing feels almost like a contradiction in terms, but I think we can make it work. And you could try it already, but it's still fresh and early. I think most of the stuff we're doing actually is on a technical side is just really firming up everything that we're doing right now so that it's like a really solid base to build the next things on. So some of that's just reliability and performance improvements. Let's like double or triple the size of our engineering team while also like retaining or improving all of our performance and reliability metrics. I think we'll probably reach like version 1.0 of the modal client at some point soon, which will give like you'll be able to right now, if you deploy a modal app, you have about 6 months before your client version will no longer be supported. And usually that just means like pip install, upgrade modal, and then redeploy with no downtime. But sometimes there's like, about like 20 or 30 minutes worth of like renaming variables or changing patterns. And that's just annoying churn that we want to reduce. And the like 1.0 version of the client will have those more stable APIs and like longer time to live, longer period to end of life. And that So that should help people build with, more confidence and for the longer term on top of Modal. Those are kind of the two big things. And I hope, like looking further, it's, more like, okay, let's start building things that are not bones, but more compositions on top of the things that we already have so that people can run workflows, so that people can maybe, so that like more, you mentioned like canary deployments. We don't have like a notion of experiments, canary deployments, Challenger, like Challenger models. We don't have any of that like built in the platform, or a model registry. These things are like, it's easy to envision how you would build them on top of these existing components, but we haven't done it yet. But we certainly will.
Nice. Yeah, I think like model registry is one of the biggest pain points right now, because I think there is not a decent one in the market.
Yeah, I don't know. I never really felt super happy with what Weights and Biases put together with model registries. And yeah, I feel like what we've ended up with is like Hugging Face repo strings are like the equivalent of your like keys into a model registry. And that feels unsatisfying. But yeah, I don't know why that hasn't been successfully like productized. But I've never like really needed to solve that problem myself, like had a super long running multiple versions model where I really like, and especially coordination across a team where you really need that, like, a formalized registry that, so I haven't tried the products deeply enough to especially since leaving Weights and Biases to have a strong opinion on that.
And if people want to learn more about you and Modal, where would you point them?
Yeah, I'm pretty active on Twitter, as is Modal. So that's Charles_IRL on Twitter and Modal_labs. That's still the main social media place for me. DMs are open. Love to hear what people are working on. And yeah, like give tips on how to use the Modal platform. On that, I post about like events and places where I'm giving talks, share podcasts like this one. Also share, like demos and things that I built on the Modal platform there. So it's a great place to get in touch. Not as active on LinkedIn. Don't feel like I've cracked that platform at all. Also do a lot of events around San Francisco. So and in New York sometimes. So AI Tinkerers, AI Demo Days, the AI Engineers Summit, the MLOps community. These are all groups that I do lots of events with, and they also have great events, great talks from people met and heard talks from people like Shreya Shankar and Eugene Yan and Hamal Hussein and others through these communities, these events, and it's a great place to learn more from people who are actually building these systems.
Yeah, and also I think like Modal has probably the best dev support I've seen so far in Slack. So always like if you run into issues, it's a good place to go first.
Yes. Yeah. I do answer support questions via my DMs, but usually the answer is that you will get better support faster if you go to modal.com/Slack and post there. It's still like our support is like the founders and engineers. So you will get and we get actually one fun thing about it is we actually don't get that many dumb bad support requests where somebody's like, how do I install Python? We mostly get people who are asking like hard, interesting questions about how do I get this working on the platform, or like, or reveal ways our API could be cleaner, or our docs are missing like an explanation of a feature. So the like quality of conversation and the technical level is still pretty high, which is nice.